Please welcome Bobby Bouwmann.
It's an extra special effect, right? Good morning, Amsterdam. Well, good morning, Amsterdam. Are we ready? LARACON, let's go. Well, as Kaneko already mentioned, I'm Bobby Bouwmann. It's awesome being here. It's actually my 10th time speaking at a LARACON, so I'm very excited about that. And we get some extra smoke today. So good. You won't see me. That's better for the talk. Can you see the screen now, or? Okay, well, we'll just wait. You can see it. It's fine. It's all good now. It's all good. So I work as a product engineer at Hospitable. We build software for vacation rental owners. Our goal is to give them as much time back as possible. And we do this by syncing calendars between platforms like Airbnb and Booking.com. We give them one unified inbox. We use a lot of AI and much more stuff. So, but that's enough about me. Let's talk about pipelines. So as the name suggests, something is being passed along in a pipeline. So you put data in it, it processes it, and then it returns or passes it through to the next pipe, and then eventually it returns something. And as you already see, there's some pizzas here. We're going to do a lot of pizza slides today. There won't be any pizzas until maybe tonight, I don't know. But you probably get hungry. So if we have a pizza here, every step is independent. Every time we add an ingredient, it's a new step. And every step can focus on a specific task. So it doesn't really care about the previous step. Like, it doesn't really matter if you add the vegetables first or the meat first. You can do it in different directions. And eventually, we will end up with a pizza with multiple ingredients. When we translate this into code, it's very much like adding multiple items to an array and returning it at the end. And a pipeline can also be a sequence of actions on a certain object. So, for example, if you have an order, you have a package, it's going from the web shop to the warehouse, then being shipped. So we're taking actions on that specific package. This is similar to performing various actions on an object. And in this case, we don't really change the state of the object. We just pass it along. Maybe we give it an update status. So you can either do both. You can change the status of this object and pass it along and take a certain action. So the pipeline pattern is very flexible there. So typically, a design pattern is a common solution to a very a common occurring problem. So the goal of the pipeline pattern is to make sure that each step is independent, and it focuses on those specific tasks and does not worry about the other tasks. And what you want to achieve is maintainability, readability, and flexibility. So you want to maintain your code, and you want to make sure that every step is well tested, and especially when it becomes more complex. If you just have to take one or two actions, then the pipeline pattern might not be for you. But if you have 5 or 6 actions you have to take, it becomes more complicated. And that's where you want to maybe use this pattern, and you can write tests for each individual step. And what a nice thing about it is that you also can reuse certain steps. I will give you examples of that later. I first want to give you a deep dive of the basics, so how the API is defined in Laravel, and then I will give you specific use cases around that. So a pipeline is always separated in 3 different steps. So we first start with a subject. So that's what we use when we call send. We pass in an object or a collection. It can be anything. That's what we call a subject. And for every pipeline that we edit, it can be one or many. For every pipeline, it will go through that subject. It will perform something on the subject and then returns it. And eventually, you will have the end result of your object. And Laravel supports multiple ways of passing in a pipeline. So, for example, you can pass in a closure. That's what the documentation, for example, shows you as well, using that. You can just pass in a class string, and Laravel will resolve the class from the container, which is very helpful. Or you can just new up your own class, pass it in as well. So you can just pass in an object, basically. And then finally, you will return it. So if we look at one of these pipe classes, you can see here that we have a basic class. It doesn't extend anything. It has a handle method. The first argument is the subject that it gets. And the second argument is the closure, which is called next. Then we perform our action on our pipe, or in this case, our object. We do something there. And then we return next with the object again. Basically, we're saying here, pass it on to the next pipe. And this approach makes it really easy to swap the order of pipes, because we're just passing to the next pipe, and we don't really care what the next pipe is, because we assume that every pipe can handle whatever the object is and do something with it. So that's the basic setup here. Laravel offers a simple way of changing how this works. So as we saw before here, it's using the handle method, which is the default in Laravel. But if you use the via method, you can set a different method. For example, if you have action classes which have an execute method by default, then you can tell the pipeline, hey, use this method instead. And otherwise, it will by default search for handle, or if you use an invocable class, it will use that instead. And then Laravel has two options. So we have a then method, which will give you a closure with the end result, and you can do something with it. Or you can return the result, so then return. It's a very self-explanatory method name. I personally like to use then return more than then, but yeah, you have two options here, so it's very helpful. And finally, there's an option to dynamically add more pipes to an existing pipeline. So you can just start a pipeline with a few things, and depending on your code, you can add more or less. So this is configurable. And Laravel has this conditional trait that is being used on almost all classes within Laravel, but now it's also used on the pipeline. So with the when method, you can just put in something that returns a Boolean, and then if it's true, it will apply something on the pipeline. So that's very helpful. You can also do your own if statement and just apply it on the pipeline. Both works. It's just, I guess, preference of syntax in the end. So this is one way of building up a pipeline as well. So I think we have a good understanding of how the API looks in Laravel. You can try this out on your own. You might have already been doing that. But today I want to focus mostly on use cases. When can you use this pattern, and when does it really shine? When is it really helpful? And then you can play around, see it as homework. You can play around with it during the breaks. So Laravel is actually using this pipeline pattern as well inside the code base. Let's have a look at this. So this is the actual kernel class. And you can see here, it creates a new pipeline, it passes in the application. So in this case, the subject is the whole application, and it sends the request. It's the request that's being is the subject. So it sends the whole request through the pipeline, and then the pipeline, the pipes that are in there, are the middlewares. So each middleware that you have defined, wherever that's coming from, it's looping over those middlewares and then passing on next. And you probably have seen it like a lot of times, right? You have a basic middleware class. It has a handle method with a request and a closure. So this is actually the pipeline pattern. It's using it the same way. And that's why you always have to return next request to make it work. Otherwise, the pipeline would stop, and it wouldn't know what to do next. OK, some more examples. At Hospitable, we sync prices between different kind of platforms, like Airbnb and Booking.com. And to do that, we need to make sure that we have the right price in the right currency, and with the right markup. And with markup, I mean, for example, you want to have your prices on Airbnb a little bit higher than on Booking.com, because the fees on Airbnb are a little bit higher. So you want to have the same revenue from both platforms. So this is where we need to apply a lot of different things on a price. So if we look into this as code, we just start with a value object, we set a base price, and then we apply the pipeline, which will then help us to change the current price to whatever we need at that point in time. So in this case, for example, we start with $100, which is just a float. We turn it into an integer because it's easier to work with. Then we apply the markup, and then we convert it to a different currency. In this case, it might be that it's going from USD to euros, so it's using the actual current exchange rate and translating it to there. So this is where it's really helpful to have a pipeline, because it will just apply the steps. And if we, for example, in the future decide that we have another kind of markup applying, we just add the class there, and it just works. You don't have to change any code. You don't have to change anything in there. So that makes it really powerful. And if we look at one of these pipe classes, you can see here we have the handle method again. In this case, we're extending a base class because we can reuse some things from there. But we start with the value object. We have the back there. We set the current working price. In this case, we're going from floats to integers, so we're setting that value. And what the nice thing is, because you now have a value object or a DTO, we change something in there, but we still have the original price. We just set the current working price, but we still have the initial price set in there. So the next pipe has all this information now. It doesn't have the initial price, but it also has the new working price. So it becomes more valuable to have this object. So you can also be smart about the order of pipes, where you just initialize some data on the object and then start applying things. So that makes it very helpful. And it's very easy to write a test for this specific case. We can just write one test that changes the price, and we can just check against the value object if the actual price is set or not. So that's very helpful. At Hospitable, we also love a lot about AI, and we use it for all kinds of things. But I'm just going to talk about messaging. So whenever we have a message, we have the whole conversation of someone, and to give a correct answer, we need a lot of extra information. And to do that, we use the pipeline pattern to determine that. So this is a little bit of a simplified version of the code, otherwise it wouldn't fit on the screen. But here we build up all the data for the pipeline. So we start with a bag. It's just an empty bag with conditions. So you can use an empty collection or an empty DTO in this case. And we can add all these classes here. So we check, are there any pets involved? Are there any children involved? When is the last message coming in? All that kind of information can be very helpful for generating a message to the host or to the guest. And as you can see, if we just, for example, they're requesting for a parking spot. Well, if we want to add that to one of the messages, we just add one more class, and it just works. The prompt will understand it now. So if we look at one of these classes, it's a very simple class. We just check, are there any number of pets? And if that's the case, then we add the condition to the bag. So we keep track of a list of met conditions. Isn't it annoying that the lid is still stuck to the bottle? Jeez, man. So let's do one more pipe, a little bit more complicated. So you can make these classes as complicated as you like. It can even dispatch a job. It can do an API call. It can do all of those kind of things. So I'm not doing too complicated things, otherwise it wouldn't fit on the screen and you wouldn't be able to read it. But you can go as far as you want with these kind of things. So that makes it very helpful. And what I really like about the pipeline pattern is that you can combine it with other patterns. Like, for example, if you have action classes, it's very easy to inject an action class in a pipe and just call the action and return something from there. So one more thing where the pipeline pattern really shines is if you have to do a lot of operations on a certain set of data. So let's say you have an incoming request that either creates, removes, updates different kind of things on a model. And the model is connected to multiple other relationships. In that case, it's very hard to do everything in your controller because it's just a lot of logic. And then the pipeline can help out there because you can define each step in separated actions, action clauses that do something. So for example, we have this update commission request. So as you can imagine, updating a commission always starts at a certain start date and might have an end date. So there might be, for some cases, it might be that it needs to create certain fees or certain commission rates at a starting point, but that also means that it might delete certain things at some times. So for example, the end or delete fees clause might, depending on the end date, delete some stuff or just set the end date based on that. So we don't really want all of this logic inside our controller. And this is where the pipeline pattern really makes it easy, because you just have input your request class with all the data that you posted. You can even turn it into a DTO if you like that. And then you can just apply all your actions that you need to do on the database to do this. And then if you wrap all of this in a try-catch or a transaction, it's actually pretty safe to do it this way. So collections are very easy to use with pipelines because it's basically just an array on steroids. So you can call a lot of methods on it and just keep passing on the collection to the next pipe. So usually you can start with an empty collection, like we did with the prompt stuff, we just have an empty collection, or we can start with initial data. But since it's Laravel, we can easily create our own custom collections, which makes it very easy to add custom methods, which makes it a lot easier to work with in pipelines. So let's say we have this controller that returns the health checks of our application. In this case, we want to have a pipeline that sends the health checks collection through certain pipes and then returns. And in this case, we're using the config because we want this to be dynamic. Depending on the environment, we want to do certain checks. So this is where you can combine all kinds of features within the pipelines. And then we have this result, which is the health checks collection. We have a method for it, has failures. Because it's a custom collection, we can add these custom methods to make it easier to read the code and to apply the code as well. So that's when we return the code. And then you can use this for external monitoring tools or use it as a health check in your Kubernetes cluster, anything that works for you. So this is the config, for example. We have the health checks list, and there's a list here of the checks that we're doing. But you can also combine this with environment variables or if statements if you want to. So it's very flexible to do it this way. And then finally, we have the custom collection class. You can easily spin up these things, right? You just create a new collection class, extend the base collection, which is Illuminate support collection. You just add your own methods, and it just works. And it's very easy to work with. So yeah, use that. Lots more examples to go. So if you are reading about pipelines or Googling about pipelines, you will probably see one or two tutorials about using the query builder as an object, because basically it's just an object, you're applying new things to it. And usually with the pipeline pattern, you're adding extra data to it. But in this case, where it might be filtering down data. So that's where the query builder comes in. But this is very helpful if you either have a post request or a get request. The query builder can help you very easily start with something and then build it down. So how does that work? So let's say we have a payouts model, and we start with a query. So you start with a query builder. That's the subject that we're going to send through. And then we have the pipelines, and those are just filter clauses. So they just apply a certain condition on the query builder. And then finally, then return. So then return returns to query builder. So the nice thing about it is we can just keep chaining on it, because we know we get a query builder back. We can just call paginate on it, and it just works. So it's very clean code. So if you would like to have like a controller that returns a list for a table, this is a very nice way of doing things, and you can easily extend by adding more filters or not. So if we look at one of these classes, you can see here that we use the when method again, the conditional when method. So if we have a certain condition met, in that case, we are applying a certain condition on the query. And since we return the query again, it will be the filtered query will be passed on to the next query builder, and so on. So you can easily build up these kind of queries. But this makes it very flexible, especially when the query becomes more complicated, when you have to do a lot of joins, or if you have to do something with relationships, or if you have to fetch some kind of data to make a where in. This is very helpful to do it this way, and it makes it very readable. Like if you go to the overview here, if you just want to know how the table is filtered, you just see the classes, and they have a very good name, so it's very easy to understand. And if you want to know more about the specific query, you just click on the class, click through there. Okay, so I want to talk about reusing pipes, because I think that's a very nice way of reusing it, because eventually you just have an object that's being passed through a pipeline, and you can do the same one twice if you want to. And I can give you the boring example of doing like a trim on a string, but within Hospitable, one of our key things that we need to take care of is double booking protection, which means that if we are syncing the calendars for Airbnb-booking.com, if a reservation comes in at the same time, we want to notify the host, because they get penalized if they have a reservation on both platforms at the same time. You can only accommodate one guest at the same time. So we need to protect against that. So, for example, in this case, whenever we get a new reservation in, we store the reservation, we check against double booking protection, and then we apply certain availability rules. And what this means is that we block the calendar around the reservation. So you might have a setting where you say, I want to have 1 day extra after a reservation for cleaning. Or in that case, we apply those availability rules to block the calendar after a reservation. And then there might be a parent-child setup where different properties are connected to each other. And then we want to do the double booking protection again, just to make sure that we are actually good. Since we are updating the calendar in those pipe classes, we just want to make sure that we actually did a good job. So that's why we do it twice. But it's totally fine, because we're just passing through the reservation every time, and we can apply the same checks again. So it's working very nicely. I love Enums. Who is using Enums in the code base? Almost all of you. Nice, nice. So I think Enums are a life hack to pipelines or to reusing pipelines. So earlier we talked about the markup rate, where we applied a bunch of pipes. So we also have the reverse, right? We get the money from, or the price of a room rate from Airbnb, and we want to turn it down to the markup rate, or we want to turn it to the base price that we show them, and that we need to sync again to Booking.com, for example. So to do that, we need to apply it both ways. And this is where an enum is very helpful, because we can just start an enum, and we can add a custom method to it, where we define all the pipes that are part of the enum. So we had the class where it goes from a float to an integer. Well, we can apply it on both pipelines in this case, because the starting result, the price back, is everywhere the same. So in this case, the enum creates a great overview of whatever is possible within the pipelines. And you can just click through the classes if you want to know more. So for example, if we have an action class or a place where we handle this, you can see here that we just pass in the enum as the through method, and just call pipes on it, and it just returns the list of actionable pipelines in there. And it's a very nice way of coding. It's very readable. If you want to know more, you just click through. It's a very, very nice way of doing things. So this is the final use case I want to talk to you about, which is called Sagas. So one downside of pipelines is that they run after each other, and there is no way to roll them back, because they're just applying things, and then that's it. You can wrap them in a transaction for your database queries to prevent issues with your database. But what if one of your pipelines is doing an API call to the external world? How do you handle that? How do you return from that? There's no way of doing that. So this is where Sagas come into play. And I don't want to go too deep into this matter. I'm going to give you homework again. You can just look it up yourself. But I would just want to give you a basic example of how this works, and then you can try it out yourself. So let's say we have a pipeline here. We work with smart logs, for example. So whenever you have a reservation coming in, we generate a code usually based on the phone number of a guest. So the last 4 digits of the phone number, that's being sent to the API of the log. And then it will set the log code. So whenever the guest arrives, they are able to check in with the log code that they received. So depending on the state of the reservation, we might create the code, or we might update the code, or we might even remove it. But this can throw all kinds of exceptions. For example, the code already exists, or there might be other things happening. So this is where the Saga comes in. So this is a very, very basic implementation of a Saga. So it's just a collection of events that are happening. And we have this method called add_compensation. So whenever something goes wrong, or we expect something might go wrong, we add a compensation to it, which is eventually just a callback that handles a certain exception. As you can see on the compensate method, which we will call on the catch, if you compensate, it will just pass in the exception, and every compensation can use its own way of doing things based on the exception. So if we, for example, look at how this works with a pipeline, we have a new value object. We start the pipeline, we send it through the pipelines, and then on the catch, we have this compensate action, where we pass in the exception, and every compensate can decide on its own exception. So there might be a specific API exception that we are looking for to compensate on. There might be another exception we don't care about, and then we don't compensate. So that's very flexible. One important thing here is that the log code also needs the Saga inside the object. So if we're going to send a value object through the pipeline, we need to have access to the Saga to add a compensation to it. So I usually just create a new value object, add the Saga in the value object, and then pass it along. So how does a pipeline of this look like? So here we're doing the external API call. And then whenever something might go wrong, we add a compensation to it. So we queue a job that will delete the code on the log, for example. So this is where we add that compensation. So in this case, when something goes wrong, we compensate. We will go back to the original state. And we can combine this with a transaction for the database part as well. So the pipeline patterns is all coming down to making it easier to understand your code. The options are endless. I hope you learned something about how you can apply this to your own code base. You get some ideas from this. That's the whole goal of it. And if you have any use cases you want to show me today, I will be walking around in the pink shirt. So finally, no pizza images. This is a stroopwafel, which is a Dutch cookie. Hospitable is sponsoring a fresh stroopwafel truck this year. I think it's in your booklet as well. Make sure you grab a delicious Dutch cookie today. Maybe we can eat one together. And come say hi to us in the pink shirts. Thank you. Oh my God.
I have questions.
You have questions? Okay, let's.
I have questions. So, Juren Divine is asking, can one of the steps invoke an early return of the pipeline without throwing an exception?
I haven't tried. I don't know. I think it will break because it expects to return next always.
Okay.
You could just not do anything in the pipeline and just return next instead.
Life finds a way.
Life finds a way, yeah.
Okay.
It might throw an exception. I don't know. I haven't tried. I don't write breakable code, maybe. I don't know. Like my AI helps me. It just doesn't write those kind of stuff.
That's always the right answer.
Yeah.
Sari is asking how to prevent a pizza pipeline to accept pineapple.
That's a good one. You should add a pipeline at the end that removes any pineapple. Yeah. I think it works. Yeah.
And I'm asking, what's your thoughts about pineapple on pizza?
I don't like it, but my wife eats it, so I have to accept it, that it exists.
Either way, you're getting a bit tricky. Okay.
But I don't eat it myself, so.
Okay, that's all. A big applause for Bobby.
Thank you, guys.
Thank you, Bobby. So.